4.5, the dot product. In the previous section, I promised you to show how to multiply vectors, right? In previous section, we learned how to multiply vector by a number, scalar multiplication. In this section, we are going to learn how to multiply vector by a vector. Actually, there are two ways. We are going to just learn one way. So, definition. If we have two vectors, vector v with coordinates a1, b1, and vector w with coordinates a2, b2, dot product between vector v and vector w is defined as a product of a1 by a2 plus b1 by b2, just the product of the x components and y components. Dot product, as you see, don't have any direction. It's just going to be one number. Let me show you example. Imagine that vector v is 1, 3 and vector w is minus 2, 4. So I'm going to find the dot product between v and w. So I'm multiplying x by x, 1 by negative 2, plus 3 by 4, y by y. Keeping the signs. So 1 by negative 2 is negative 2. This one is going to give me 12, and the final result is 10. You see, 10 is just a number. It's not two numbers. It does not have any direction. So dot product is a scalar. Okay. What are the properties of the dot product? First, why do we call it dot product? Initially, when people invented dot product, they were not placing it as a product. They were placing it as a dot between two vectors to separate it from normal multiplication. But now we just kind of put a product and just say it's a dot product. Okay. What are the properties of dot product? There are some properties. Property number one. If I multiply u by v, it's going to be same as v by u. Well, if you just look at the idea or as the definition, if you switch v and w here, you're going to just switch a2 and a1, b2 and b1, because they are just products. It does not matter. Actually, they're going to give you same numbers, so the result is going to be same. So multiplication of two vectors in any order, dot product is going to give you the same result. Property number two, how to open parentheses. Well, if you do need to multiply dot product by the sum of two vectors, what you can do, you can multiply first vector by u, and you can multiply second vector w by u, and then add the results. Going to be no difference. Property number three, if you multiply vector by vector itself, you are going to get the length of vector v, or magnitude squared. For this one, we probably need to show why it works. Dot product of vector by itself, it's v1, v1, if vector v is given by v1, v2 components, plus v2 by v2 if we multiply vector by itself, right? Which is going to give us v1 squared plus v2 squared, which can be written as a square root of v1 squared plus v2 squared, Square and the square root cancel each other, right? And we do remember that coordinates v1, v2 squared and the square root, it's actually length or magnitude. So magnitude squared is going to be the dot product. Okay, the last property which does not fit probably on the board, I'm going to write it down over here, is what is going to happen if I multiply dot product by zero vector. I'm going to just get 0. You see, interesting, this 0 is different from this. This 0 actually means 0 vector, vector 0, 0. This 0 is just a normal number, or normal 0. Okay? Okay, so basic properties. Now let's talk a little bit about angle between two vectors and how dot product is helping to find it. Angle between two vectors. So what do we mean by angle between two vectors? Well, imagine that we do have two vectors, vector v and vector u, and you want to know what is the angle between them. Like, is it 30 degrees, 40 degrees, 50, 60, whatever. How are we going to find it? First, I'm going to draw additional vector a here, and I'm going to make it look as a triangle. Vector a is going to go like this. Connect this part and this part. Now guys, if you look at u plus a, u plus a, you are going to see that it equals to v, right? From where you can write down that a equals v minus u. So that's going to be expression for vector a. What I'm going to do over here, guys, I'm going to find dot product between vector a and vector a. I remember that this is supposed to be length of vector a squared. I already proved it before, right? But I'm going to literally multiply vector a by vector a. So write down v minus u multiplied by v minus u. So what I'm going to have? Well, v by v is going to be v by v plus u by u is going to be u by u. These two minuses are going to kind of cancel each other. And then minus u, this u by this v, and minus this u by this v. Well, what I have over here, it's length of vector v squared, length of vector u squared, and these are two vectors u, v, which is just a dot product. And that's equals to length of vector a squared. Does it remind you something when you look at this triangle? The square of this side, the length is actually length of the side, right? Square of this side, square of this side. It's supposed to remind you exactly cosine's theorem, which looks like this. Length of opposite side to angle theta equals length squared of this side plus length squared of this side, length means this bars, minus 2 length of side v by length of side u, and the cosine of theta, that's cosine's law. We're going to compare these two expressions and see that these two are same, these two are same, these two are same, so this must be same. I'm going to write them down. Minus 2uv, that's dot product, equals minus 2v length u length by cosine of theta. I'm going to now cancel minus 2 and get a very nice expression for the dot product. The dot product between two vectors equals magnitude of the first vector, I put it first to make it same over here, magnitude of the second vector multiplied by cosine of the angle between. Usually people don't use dot product to calculate, or let's say people don't calculate actually dot product using this formula because it's much easier to multiply the coordinates. But you can solve it for cosine and kind of use dot product and length of vector u and length of vector v to calculate cosine. Let me write it down. I'm going to copy it over here. So cosine of theta, I solve for cosine dividing by this length and by this. That's u v dot product over length of u and length of v. So, well, why it's important to know cosine? Well, it's important to know cosine because we want to know like how the vectors are kind of connected in space, how they look. So what I'm going to do, I'm going to give you one example and then I'll ask you to solve one problem on your own. So my example is vector u equals 4, negative 3. Vector v equals 2, 5. And I'm asking you, what is angle theta? Or at least what is cosine of theta? So what I'm going to do, I'm going to just plainly use the formula. So cosine of theta equals dot product x by x, 4 by 2 minus 3 by 5, length of u vector, the square root of 4 squared plus negative 3 squared, length of v vector, that's a 2 squared plus 5 squared. Here I'm going to have 8 minus 15, which is going to give me kind of negative 7. In denominator, 16 plus 9 is going to give me 25, square root is going to be 5. This one is not going to give me anything good. It's 25 plus 4 and the square root of 29. Okay, if you take a calculator, calculate this number and then take, like, write it down approximately. It's negative 0.26. And theta is cosine inverse of negative 0.26. That's going to be 105 degrees approximately. Okay? So that's how we calculate the cosine. Now I'm going to give you the problem and you try to calculate it while I'm cleaning the board and then I'm going to do the cosine. So self-work. U equals 1, 2, V equals negative 1, negative 1. try to calculate angle theta, or at least cosine of theta, if you don't have a calculator. And I'm going to clean up the board and solve this problem myself, and you can just stop the video. Okay. Okay, let me get a different marker and pair it of green. So according to the formula, cosine of theta is going to be the dot product. 1 by -1 is -1, 2 by -1 is -2. Denominator is square root of 1 squared plus 2 squared, and the square root of 1 squared plus 1 squared. Doesn't look very nice, but that's -3 divided what is square root of 5, and this is square root of 2, so -3 over square root of 10. And what are we going to have for the angle? Well, we can just calculate cosine inverse, or you can leave your answer like this, if I'm not asking you specifically about angle theta. Okay, interesting facts about this cosine and kind of vectors. We're going to start with first kind of setting up. What if cosine of some angle theta equals 0? What does it mean? Cosine equals 0 when theta equals 90 degrees or negative 90 degrees, right? Theta 90 degrees means that these two vectors v and w are perpendicular. So we're going to call two vectors orthogonal if cosine is equal to 0. Okay? Another option for cosine is to be equal plus or minus 1. What is going to happen? We know that plus 1 happens at theta equals 0 and minus 1 happens at theta equals 180 degrees. How the vectors are going to look? Well, if it's a 0 means that they're exactly parallel. 180, they're kind of anti-parallel. So one vector goes like this direction, one vector goes that direction. You see that finding cosine can tell us how the vectors are kind of looking in space relative to each other. Perpendicular vectors are going to give you cosine equals to 0, and parallel vectors either 1 or -1. Usually the problem is going to sound like this. Find if the vectors are parallel, perpendicular, or neither. Neither means that they do have any other angle between like this, from 0 to 180. I'm going to solve example, and then I'm going to give you a couple of problems to solve on your own, okay? So my example, vector v is going to look like 2, -1. Vector w is going to look like 3, 6. 3, 6. Let's see if these vectors are parallel, perpendicular, or neither. Well, I'm going to start with writing down cosine of theta and the dot product, VW. So it's 2 by 3, 2 multiplied by 3 minus 1 over multiplied by 6. Supposed to be actually length of vector v and length of vector w, but I already do see that it's 6 minus 6, which is going to give me 0, no matter what I have in denominator. So the cosine, no matter what number I'm going to have over here, is going to be equal to 0, which means that these two vectors are perpendicular. Okay, let's consider a case of parallel vectors. Vector v equals 2, -1, vector w equals 4, -2. You see that why they are parallel. I just took vector v, multiplied it by 2, and get vector w. So they are billed as parallel. Let's check if we are going to get a correct answer for cosine. So what is going to be cosine of theta here? Did I use this one actually? Yeah, guys, I think in my notes, 2 minus 1, in my notes I considered, okay, I'm just going to do this one as an extra example. I did not consider anything in my notes. Okay, so we are going to have the dot product 2 by 4, which is 8, -1 by -2, which is 2, right? So it's 8 plus 2. Length of this vector, we already calculated it as square root of 5, right? The square of this and square of this is 5. Square of this and square of this is going to be 16 plus 4, which is going to give me kind of 20. So it's 10 over square root of 5 and square root of 20, which is going to give me 10 over square root 5 by 20 is 100, and that's going to give me 1. Exactly what I was expecting. So these two vectors are parallel. Okay, now I'm going to put two problems for you to do on your own, and I'm going to put solutions after, okay? No, okay, I'm going to erase it. So I'm going to give you two pairs of vectors, and the question is going to be find whether they are parallel, perpendicular, or neither. Case A, v equals 1, 2, and w equals -4, -2. And B, v equals 1, 2, and w equals 3, 6. So, perpendicular, parallel, neither. And I'm going to count to 5, and you can stop your video and do it on your own, and I'm going to solve it, of course. So 1, 2, 3, 4, 5. I'm going to start with problem A. So, cosine of theta, dot product, 1 by -4 plus 2 by -2, and the length of this and the length of this. This one we already know, that's 1 squared plus 2 squared is square root of 5. 16 squared plus 4 squared is square root of 20. What I have in numerator? -4, -4. So I'm going to get -8. 5 by 20 is going to give me 100, and I'm going to have -8 over 10, which is going to give me -0.8. -0.8 is neither equal to 0 or equal to plus minus 1. So these two vectors are neither. B, these vectors. Cosine of theta, 1 by 3 plus 2 by 6. Doesn't look like they're going to give me 0 over here, no minuses, right? And I'm going to have a square root of 5, and this one is going to give me what? 9 plus 36. Numerator, 1 by 3 is 3, 2 by 6 is 12, so it's 15. In denominator, 5, and this one is going to give me 45, right? Okay, 5 by 45, I think it's 225. So square root of 225 is exactly 15, so I'm going to have 1, and these two vectors are going to be parallel. Can we see that they're parallel? Yeah, actually, if you multiply this by 3, you're going to get this. So it's much easier to just find out that they're products of each other than to do all this stuff with cosine. Can you do this? Can you do the products? Yeah. If you see, obviously, like that this vector is multiplied by 3 to get this vector, you can do it too. Okay, that's all for today, and this is all the lecture. Do your homework, email me any questions if you have. Thank you.